to begin here. As a quick introduction, Network Consulting Services is a platinum partner of Imperva. We specialize in designing and implementing data security systems. Joining me today is Carrie McDaniel from the Imperva CounterBreach team. For those of you that are not familiar with Imperva, Imperva is the market leader in web application firewalls and database protection. In fact, if you research Imperva on the internet, you'll find that they're in the extremely rare position of being the only web application firewall company in the upper right-hand quadrant of the Gartner Magic Quadrant for web application firewalls, and has held that singular position for 2 straight years. In addition, Imperva is a market leader in the database and access monitoring and blocking of suspicious user behavior. CounterBreach is the pinnacle of database protecting and monitoring by providing clear reporting and alerting for suspicious behavior on databases. Today's presentation will cover how CounterBreach is used to layer on top of database protection. I would like to present Carrie McDaniel to you as the presenter today. And Carrie, I will make you the presenter and you can share your screen. Just 1 second. All right, Carrie, I think it's all yours there. Take it away.
Great, thank you so much. Hi, everyone, and welcome to our webinar today. My name is Carrie McDaniel, and I'm on the product team at Imperva. So today we'll be talking about Imperva CounterBreach, which is a brand new product line from Imperva, which is all about detecting and mitigating insider threats. From an agenda perspective, I will go through an introduction of the CounterBreach solution, and then I'm also very pleased to show you a demo of the product today. So as mentioned in the introduction, Imperva is very focused on data protection and also protecting the way the data is accessed through web applications. And as we've worked with our customers over the years, we've seen that when it really comes down to it, the elephant in the room are really the people on the payroll. And the reason for this is that users have legitimate access to sensitive and valuable corporate data, and as a result, they inherently put data at risk. At Imperva, when we talk about the insider threat, we place this threat into 3 main categories. And the first category are users that are compromised. So these users typically they may click on a spear phishing link, or they may open up a malicious file or visit a malicious website. And the result of that is it allows attackers from the outside to gain access to users inside the network and gain control of their user credentials and attempt to use those credentials to access enterprise data. So the first category that we address is compromised users. The second category are careless users, and these individuals typically do not have any malicious intent, but they're doing things with corporate data that could put it at risk. For example, they may decide to put data on a USB drive or upload it into their own personal cloud backup service, such as Dropbox or Box. And the third category are malicious users. And while this category does represent a relatively small percentage of users in the organization, the reality is that they are highly effective. And the reason for this is that they have a very wide window of opportunity, and they know exactly where to find the data that they're after, and of course they have legitimate access to that data. So these are really the 3 buckets of insider threats, and when it comes to really being able to solve the insider threat problem, you need to be able to address all 3 of these categories. We're seeing a lot of traction around this topic from the analyst community as well. Gartner has issued a number of reports on managing insider security threats. So we're definitely seeing this is a trend. The analyst community is hearing about it from their clients. And what it comes right down to is that, insider threats are very tough to detect. They are, users need access to information to do their jobs. It looks legitimate, and so it's very hard to distinguish between what is legitimate and what is not legitimate. Imperva approach to detecting and containing data breaches consists of really three main questions. And the first one is exactly who is accessing my data. And this is really the foundation of being able to uncover insider threats, because when it comes right down to it, insider threats are going after enterprise data, whether that data is stored in databases, file servers, or whether it is data that's being stored in SaaS applications like Salesforce.com, Microsoft 365, Dropbox, etc. And when it comes to understanding who is accessing data, it's important to not only monitor a subset of your users. So for example, your privileged users, because the reality is that anyone in the organization can become compromised, they can do careless things with information or be malicious. So you really need to have a handle on the actions of everyone in the organization. And the second question is that access to data okay? And this is the gray area that we are trying to address with CounterBreach, because users access data all the time, but how do you really know when there is a worrisome data access versus a normal data access? And then the last one is, once you uncover an incident, how do you respond quickly so that you can prevent a data leak, a minor data leak from becoming a very serious breach? So these are the three main questions that we come to answer with our solution for solving the insider threat problem. And we built our solution to map to these three key requirements. And like we mentioned in the introduction, Imperva has been monitoring access to data repositories for over 15 years. This is our bread and butter. We have thousands of organizations around the world using our products to monitor access to databases and file servers and cloud applications. And we also enable, based on security policies, the ability to quarantine users who are violating security policies. And what we're doing is adding the ability to learn and detect. And what we're doing here is we're using machine learning and the ability to do peer group analytics to establish a baseline of what typical access to data looks like, and then we look for critical deviations from the norm. So let's take a look at the solution one level deeper. And you can see up at the top that we're following the monitor, the learn and detect, and then the block and quarantine system that we set up in the last slide. And what we're doing is you can see here that we're getting visibility into data access from Imperva SkyFence and Imperva SecureSphere. And Imperva SkyFence is our CASB solution, so it monitors access to cloud applications. And Imperva SecureSphere is monitoring access to databases and file servers. And we're feeding that visibility into our behavior analytics engine. And that is performing machine learning on the audit logs that we receive from Imperva SecureSphere and Imperva SkyFence. And machine learning, of course, is a very popular topic right now in enterprise security. However, the reality is that when it comes to machine learning, it's not only about math, it's also about domain expertise. And so we're going to talk about that in the next slide. Behavior analytics.
If I can interrupt you, may I interrupt you for just a second? We do have a question here on this. On this, does CounterBreach do analysis by monitoring database traffic, or is there an agent installed on the database? How does it gather the information?
Oh, that's a great question. So we are, like I mentioned, monitoring access to databases using SecureSphere, and the SecureSphere solution has very flexible deployment options. A lot of our customers will install agents on the database so that they can monitor local traffic. However, the solution can also be deployed in sniffing mode, and if they would like, blocking mode is also, inline mode for blocking is also available, but we do block via agents as well.
Thank you.
So behavior analytics, when you talk about machine learning and the ability to do peer group analytics, this is what we call heuristic in nature. And we have also added another layer of capabilities into the solution called deception tokens. And deception tokens, what they do is they very accurately pinpoint end user devices that have been compromised by external attackers. And so we're going to talk about that more, but what we've done here is put together a multi-layered solution that is heuristic and also deterministic in nature so that we can very accurately identify insider threats. Any incidents that we receive from behavior analytics or deception tokens are populated into the CounterBreach user interface, which I'll show you at the end of this presentation. And then from there, once incidents are detected, the SkyFence and SecureSphere solutions can block access to data repositories so that security teams can take the time they need to perform forensic investigation and understand exactly what's going on and also contain any data leaks. So
Carrie, I've got one more question for you. So I apologize for keep interrupting you on this, but I just want to make sure that we get these answers. You've got on the slide there Imperva SkyFence and Imperva SecureSphere, and the question that they're asking is CounterBreach only used with SecureSphere and SkyFence, or is it possible to use it as a standalone?
Yes. CounterBreach sits on top of our SecureSphere and SkyFence solutions. However, one thing I mention is that it doesn't require the use of the database product, the file product, and the SkyFence product. You can use one or more of those solutions. And the reason it's not standalone is because we are performing machine learning based on inputs from those products. So you do need one or more of those products to use CounterBreach.
Thank you very much.
So in the last slide, I mentioned that machine learning is more than just about math. It's also about domain expertise because since users have legitimate access to data, it's difficult to distinguish what good data access and bad data access looks like. And so what Imperva brings to the table is domain expertise when it comes to data access. And what I mean by that, you can see on this slide that there are a number of different attributes that pertain to the user and also to their data access. So we have very granular visibility into data access all the way down to the table name, the schema, the operation response time, the number of rows. And so we learn how users typically interact with the database based on these very granular attributes. And then that's how we're able to detect deviations that indicate something very unusual is going on with your enterprise data. And the reason this is important is because ultimately, when it comes down to it, when you take a look at all the major data breaches that have happened in the last couple of years, typically a user on the inside of the organization is always involved in some way, whether that user is compromised or doing something careless or malicious. Typically, users are always sort of a gateway to enterprise data, which exposes the organization to the risk of a data breach. So having that very granular visibility is what allows us to be very accurate and really pinpoint actual data breaches versus just side effects of data breaches. And to provide some examples here of the benefits of having visibility into detailed visibility into users and data, you can see here some of what we consider the hardcore indicators of data abuse. And for example, one here is excessive database record access. So we can see details about the user, but we can also see all the details about how that user interacted with the data, such as the number of rows they queried, the type of SQL operation, the database name, and how sensitive that data was, which really gives us the ability to pinpoint serious misuse of enterprise data. Another great example, and this is one that we see often before users leave the company is the slow theft of data. And so one thing on the file side, from a file example, is we can see users who are slowly taking data either from their personal file share or from the department file share very slowly over time, because perhaps they're about to give their 2 weeks notice, or they want to take information with them to the next company. So these are the types of things that we're able to detect from the perspective of enterprise data. What I'd like to do now is drill down a bit deeper into how we develop our behavioral baseline and how we develop this baseline based on many different features of data access. And in this example, imagine you have multiple users accessing the PCI database. So what we're able to learn is who is connecting to the database. Is that an application that's connecting to the database, or is that actually in reality a human or an interactive user that's accessing the database? So we do this by learning how applications interact with the database and how others interact with the database, which allows us to distinguish. Then we learn how they connect to the database. Are they using SQL query tools? How are they actually connecting to the database? The next one is, what data are they accessing? Are they accessing data that is considered sensitive, meaning applications usually access it, so we learn that it's actually considered business critical data, or is it metadata that's being used by DBAs exclusively? Are peers accessing data in the same way? And peer group analysis is a great way to be able to distinguish malicious behavior from normal behavior. And that's because we're able to compare a user's behavior to the rest of the department and also to the rest of the organization, which helps us understand whether user access is inappropriate or appropriate in comparison to the peer group. How much data do they query? Do they typically query a number of database tables, or do they usually only query 5 or 6 for maintenance purposes? So we can find deviations in amounts of data they query. And then the last element is time of day. Are they a contractor that's working 9 to 5, or is it someone who usually works late at night? So we take all of these factors into account when we establish our baseline, and then we detect deviations from this baseline. What I'd like to do now is share an example from some findings from our current installments of the product. And the example I'm sharing with you is an organization in the transportation sector. And they have a database that they maintain strictly for the FBI to access. What they do is they maintain a record of all vehicles that are crossing toll roads in the United States. And they maintain this information in a database that the FBI can access via an application. And what we uncovered with the CounterBreach product was a human user, an interactive user from the transportation organization itself who directly queried information from that database. So it wasn't someone from the FBI, and it wasn't someone accessing the information via the application, which is what flagged the incident to us. And of course, the risk here is the compromise of personally identifiable information, all kinds of regulated data about, license plates and individuals' names. And when this incident was brought to the attention of the security team, the final assessment was that this was inappropriate data access, and ultimately this individual was dismissed from the organization. So earlier I mentioned that we have 2 key capabilities of CounterBreach. The first one is behavior analytics, which is heuristic in nature. And the second capability is called deception tokens. And what this does is it adds a deterministic element, and it also helps to very accurately pinpoint user workstations, such as laptops or desktops that have been compromised by external attackers. And the way deception tokens work is we are planting fictitious information on user endpoints such as laptops and desktops. And these fictitious tokens include things such as database credentials, links to network files that look enticing, and also web browser cookies that look like they could help an attacker log into an application. And these tokens are completely passive. They're not introducing any instability or running any processes on the endpoint. All they're doing is attempting to lure attackers that may compromise endpoints. You can think of tokens sort of as the things that hackers look for when they penetrate an organization. So what are the types of things they're going to look for in order to navigate laterally, in order to access enterprise data? These are the types of things that we're planting on endpoints. Now, the way that we do detection with deception tokens is if an attacker takes one of our tokens and attempts to access a data repository with those tokens, then we will flag that in real time. And it's important to note that they will not be attempting to access production data repositories, but the tokens will point to fictitious data repositories. And so the whole point here is to be able to find attackers that are looking to explicitly and deliberately access enterprise data. So once we detect incidents from behavior analytics or deception tokens, we populate that into our user screen, and so into our GUI. And so what you're seeing here is a user screen, and you can see that we show access to databases, file servers, and cloud applications, all from one user interface. And I will show you a demo of that just shortly here. Larry, do we have any questions in the interim?
Nope, so far we're good.
Thank you. So what I'll do now is switch gears here and switch over to my internet browser. Okay. Great. So what you're seeing here is the dashboard of Imperva CounterBreach. And what I'd like to show you first is up at the very top is our ability to see all of the assets that are being protected by CounterBreach. So in this case, we have 73 databases that are being protected, 3 file servers, and when you see up here 122 endpoints, that means that 122 endpoints have deception tokens deployed on them. And just moving down, there are a few different ways that you can take a look at the incidents that CounterBreach has detected. The first way here is you can see all of the currently open incidents by level of severity. And then moving down a bit further, you can see all of the entities with the most serious incidents associated with them. So the users with the most severe incidents, the endpoints that are the most risky, and also servers with the most incidents associated with them. So you can drill down into incidents in a number of ways. And I'd also like to share with you here just the number of events that we are analyzing. You can see here that we are processing millions of events. And the reason we're able to do this, we actually don't require a big data platform under the hood for this product, because since we're using our own proprietary inputs into CounterBreach, we're able to use a lot of very sophisticated compression techniques, which allows us to process just tons of logs without requiring a very heavy virtual appliance under the hood. So what we'll do now is we will jump into the most risky user that we have here, which in this case is John Hydorn. So we'll go ahead and click here. And when we click there, we see the user screen. And up here you can see all of the details associated with John. So his email, his phone number, which office he works at. You can see incidents and anomalies. And then we can also take a look at the different endpoints that he uses to access enterprise data. We see the databases he usually accesses, as well as the file servers he typically accesses. And if you have the SkyFence product, you can also see his access to the cloud applications. So
Carrie, we did have a question come up. Sorry to interrupt you. What is the difference between an incident and an anomaly?
That's a great question. So anomalies are what we consider low-level potential indicators of compromise. So they could be things such as a user worked late one night, and that's not something that we necessarily believe you should look into right away, but it's just kind of an FYI. So anomalies are basically all of the unusual types of things that we find, but we won't necessarily consider them an incident. Incidents can be two things. They can be an accumulation of a number of anomalies put together for a user, or they can be something of very high severity that we believe requires looking into. So we expect our users, the administrators, to act on incidents, but the anomalies are there, and we keep a record of all the anomalies for your reference. And this here, what you're seeing, the 14 anomalies, we're showing the number of anomalies that John has in comparison to the rest of the organization. So in this particular environment, John is considered high compared to the rest of the organization.
Thank you. That's perfect.
So right now what we'll do is we'll segue into the incidents. So we can see all of the incidents associated with this user. And when we go here, we see that there's one critical incident and two high severity incidents. So in this case, we're going to go ahead and take a look deeper into suspicious application data access. When we click there, we see a description of what happened, and in this case, it's the fact that John, as an interactive or a human user, accessed application table data on a specific database. And we also explain what the implications are of that. In this case, it's a user who could be violating access privileges by not accessing the information via an application, and basically it's a risky behavior that we like to flag. So moving down a little bit more into the details of this incident, we can see that under typical behavior, these are the applications that usually interact with this database. This is what we consider normal access to this database. And when we take a look a bit deeper, we can see what the human user, what John was doing on that database. We can see that he was accessing, he was performing selects on this number of database records. And so this is basically how the human is interacting with the database, where these are the applications that are typically the ones accessing the database. So we can see here that what John was doing was unusual compared to normal database activity. So then from here, what we can do is, in some situations, there are scenarios where there is a database maintenance project going on, or maybe a data migration project. And in these situations, you may want to whitelist an event of this nature for a period of time. So we allow you to create a whitelist rule. So here you can type in the name of the rule, such as migration, and you can set an expiration date, which is basically sort of like a snooze button, so you can allow the user to do that for a period of time. And we automatically populate all the attributes of this anomaly so that you can create your whitelist based on the attributes that we uncovered. So the whitelist capability is available. So once we do that, once we've looked into the anomaly, we can go back to John's profile and we can take a look at his typical access. So Once we've seen that he's done something unusual, we can say, I wonder what he's been doing normally. So we can take a look at his typical working hours, the databases he usually accesses, and then more detail about the database access he usually performs, as well as his usual file access. And here you can see that he accesses, around 300 files a day, whereas the rest of the information technology department accesses around 100 files a day. So his behavior is considered a little bit unusual compared to the peer group, but not in comparison to the organization. And then from here, what you can do is, once you've determined that what John did was considered unusual or inappropriate, you can go ahead and take a look at his employee details. You can also take a look at his manager, who in this case is Miriam, and you can give Miriam a call and sort of continue doing your due diligence by finding out if this action on the database was considered sanctioned or unsanctioned. And so with that, that concludes our demo of the CounterBreach product. As you can see, it is looking for unusual activity on databases, file servers, and cloud applications. And what it does is it helps our customers really speed up the forensic investigation process and find the critical incidents that pertain to enterprise data.
Thank you, Carrie. I appreciate your time. I think we've covered most of the questions during the actual presentation, so I'm glad we were able to cover those, and I'm sorry for all the interruptions I gave you at that time. Let me take back control for just 1 second. Let's see. There we go. Okay. Just wanted to make sure that you knew how to get a hold of us if you'd like to. We'd like to follow up with each and every one of you if we can, but if it's a little later in your organization's time frame to be looking at CounterBreach, please feel free to get a hold of us. You get a hold of me or particularly Dave Hammer at our organization. This is his email address and this is his phone number. And Carrie, I want to thank you for your time today. It's been a great presentation, and we appreciate everybody taking the time out of their day to see Imperva's CounterBreach. And we look forward to seeing you on our next Imperva webinar series. Thank you for attending.
Thank you.